Hello everyone. Today we're going to talk about neutralization equations. So you're going to need your reference table, something to write with, and your notebook. Your goal today is going to be writing balanced neutralization reactions. So we're going to see what we get when we mix an acid plus a base, and we're going to write the final products as well as balance those equations. So what we're going to start off with is reviewing how to write ionic compound formulas, because you need to be able to do that in order to write the products. We're going to talk about what neutralization actually is and do a couple practice problems. What I would like you to do is first try to write the formula for the ionic compound calcium bromide. Quick reminder, you're going to have to look up those charges and crisscross the charges. So like I said, you have to find the charges of each ion in the periodic table. You're going to crisscross your charges. And step 3 is actually reducing to the lowest ratio possible if you have to. In this case, you did not. So what you should have found is calcium has a +2 charge because it's in group 2. Bromine, group 17, halides, has a -1 charge right off your reference table. We always use the first charge for nonmetals. We crisscross our charges, and we end up with Ca1, Br2, calcium bromide. Another quick recap, but acids and bases. So Arrhenius acid, again we're going with Arrhenius theory right now. Acids dissociate in water, so do bases. Strong acids and strong bases are going to 100% ionize or dissociate in water. So for example, if we have our acid here, we add it to water, and it's going to break up into a proton plus our other anion, but the main part here is that acids are a proton donor. Bases are going to break up in water, and we end up with hydroxide. Alright, let's talk about the new stuff. So neutralization. When you hear neutralization, take a second, think of what that means to you, what that relates to with what we've talked about previously. But a neutralization reaction is with acids and bases. It's when you have an acid and base as the reactants. So they're going to be on the left side of your chemical equation. It is a double replacement reaction, but it's a specific type of double replacement reaction. And it always produces a salt, so an ionic compound, and water. So what you have to be able to do, identifying wise, is see that if you have an acid and base and it's making a salt and water, you have a neutralization reaction. Lastly, the important part about neutralization reaction is the word neutral. So if something is neutral, when we're talking about acids and bases, it means it's a pH of 7. So you're taking an acid on the far side of our pH scale, a base on the other side of our scale. When you mix them together, you get something neutral. And salt water, again, key here, water, is we have a neutral pH. Same amount of protons, same amount of hydroxide ions. Alright, so I'm going to walk you through writing out a couple neutralization reactions, starting with this first example. So we have hydrochloric acid. Again, it starts with an H, so it's an acid. And we have potassium hydroxide, OH, a base. I'm going to put everything on the screen, but we're going to go step by step so don't get overwhelmed by the fact everything is written out. Alright, so first, we're going to identify the reactants. We, again, have an acid plus a base, like I just said. We're going through a neutralization reaction. When you realize there's a neutralization reaction occurring, again, our products are always going to be a water and a salt. So now we're going to write our products. We have HCl plus KOH. The H from the acid is going to combine with the OH to make water. So here is water, HOH, which you can rewrite as H2O. Either way is okay, but just understand that the H is coming from the acid, the OH is coming from the base, plus we get our salt. Again, this is a double replacement. This H is swapping with this K, so K, potassium, is now going to combine with chlorine. So we get the salt, potassium chloride. And remember, this is an ionic compound. It's a salt, so I did crisscross my charges and I showed that right here for you. If you need to, pause this, write it down, even re-listen to my explanation for it. Oh, and one last thing. Step 4 is really checking to make sure this is balanced. Right now, because we have all +1 and -1 charges, this is a balanced chemical equation. Here's a second example. So we have sulfuric acid, H2SO4, and sodium hydroxide, an acid, plus a base. So again, first thing here, just identify the fact you have an acid and a base. When you have an acid plus a base, realize neutralization is occurring. Our products are going to be a water and a salt. That is the bare minimum of what you need to take away from this presentation. We're now going to write our products. So we have H2SO4 plus NaOH. Again, an H from the acid is going to combine with the OH to make water, HOH. Again, you can write this as H2O. And then we're going to get a salt. So this is a double replacement. We have a swap here. Sodium is now going to combine with SO4. The H is combining with OH. Now, here's where you got to pause a second and do your crisscross. So sodium is group 1. It has a +1 charge. Sulfuric acid is a polyatomic ion from table E. It has a -2 charge. We crisscross and we get Na2SO4. That is our salt. Last step, make sure our equation is balanced. This one is not. So if you take a look, we have 2 H's. So I have to put a 2 here. So we have 2 H's. I also have 2 H's from here, so really we have 4 H's on this side, 4 H's on this side, 2 oxygen, 2 oxygen, 1 SO4, 1 SO4, 2 Na, 2 Na. Now here's our third one. What I would like for you to do is go through those steps yourself. So while the video is paused, write the entire balanced chemical equation for this neutralization reaction. Alright, so I wrote less this time, but let's go through it. We have a base plus an acid, so again this is a neutralization reaction. It doesn't matter which way your acid and base are written, or your water and salt for that matter, right? 3 plus 2 equals 5, 2 plus 3 equals 5, associative property. So we have a base, LiOH, plus an acid. It's going to make water. Again, the H comes from the acid, the OH from the base. We have a double replacement occurring. These two are switching places, which means lithium is now going to combine with chlorine. Lithium has a +1 charge, chlorine has a -1 charge, so we get Li1, Cl1 as our salt. Our last step is to make sure that we balance. If we take a look, we have 1 lithium, 1 lithium, 1 OH, 1 OH, 1 H, 1 H, 1 chlorine, 1 chlorine. This is already balanced. It's a 1 to 1 to 1 to 1. And here is our final equation written out. Again, you can leave it HOH or write it H2O. It's a preference. What I would like for you to do is go do the practice questions related to this. Otherwise, if you have any questions, feel free to email me. Otherwise, have a good day.